All right, welcome everyone to Spark Teacher Training. Today we are working on session number 3, which is design, and we are going to be talking about the design for the apps and or games that your students are going to be expected to make at the competition. So the entire time that we have today, our hour, Christina is joining us. She's kind of hanging out in the background. So if anybody has questions on the design presentation she gave yesterday, excuse me, you can chat window. She's actually typed hello into the chat window, so feel free to ask her questions there. If you're not sure how to pull up the chat window, just move your mouse to the left-hand side of the Hangout window, and you'll see some buttons in the upper left-hand corner. The top one is the chat button, so that'll pop out the chat box if you're participating in the actual Hangout. If you're watching us on YouTube, feel free to leave comments on the YouTube video after the fact or in the live chat window on YouTube. I'll be monitoring the YouTube window, and Christina is available in the chat so she can answer any questions that you have. As far as our session for today, go over how to make a game, but we're going to use some of the design tools that are built into Scratch. So we're going to start just talking about general game design rather than actual visual design. And then as we get to the individual sections, we'll talk about the visual design as well. So if you've watched any of our previous teacher training videos from prior years, you might be familiar with this game that we're going to be working on. It's just a really nice sample game that we can set up that teaches all kinds of different concepts. So we're going to do that for the next few days, and it'll get you kind of the basics of how to put things together. And while we talk about it, we'll kind of dive into the other design aspects of this. So first off, the most important thing, or the most important advice that I can give to students when it comes to making a game, and so as teachers, you'll need to know these kind of same ideas or these same steps to go through. And we kind of talked about them yesterday with the Smithsonian people, with Tracy and Tim. But the biggest part of making a successful game, and what I find helps students, and what the most successful students, the ones that win, always end up doing, is they end up first looking at the problem that they're trying to solve. So in this case, what we're working on is we want to make a game where our character, Scratch the Cat here, can move left and right through player control. And then as he moves left and right, items fall from the top of the screen. Some of these items will be good items that will give him points. Other items will be bad items that will take away lives or take away, his ability to do things. So if he hits too many of them, then he loses. So before we even start coding anything, the design of our game forces us to ask, what is the actual mechanic of our game? What is the point of the game, or how do the players actually interact with the game? And so to do this, typically what I like to do is start off with either the visuals of the game, just to kind of see what they're going to look like. And when I work on visuals, Christina talked about this yesterday, you want to storyboard what the game looks like. So typically we would just draw out a scene with Scratch the Cat at the bottom, the items falling, from the top of the screen. We would want to mark out places in our user interface, or in this case, our stage, for where we want the score to go. If we're going to use a high score, we need to have a place for the high score and for the regular score for the current round. In prior projects, we've given the player a limited number of lives that they have in order to complete this. So you also need to figure out a space for how many lives the player has, and how do you display that to the player. So when we're looking at our screen, we need to be very, very aware when we plan this out of exactly where the user is going to be, where the player is going to be, where the objective of the game is going to be. So in this case, the items that fall from the top of the screen. And then what actually happens when those items fall from the top of the screen. What speed do they fall at? What happens when they touch our character? What happens when they touch the ground? Is there anything else special that we need to account for when using this. And a common mistake that people make when they're planning this stuff out is that they don't actually, they come up with the visual design first, or they come up with the way that the game looks without thinking about how that affects the way that the game plays. And that's the portion that we're going to talk about today, the way that the game plays and how the visual design impacts that, but also how the actual controls, for example, and how the way that the screen is laid out affects the actual gameplay. Is the game fun? Is it challenging enough? Is it too easy? How is it getting more challenging? Or how is the player prevented from becoming bored playing the same thing over and over? So those are some of the things we're going to talk about. So I'm going to load up a previous project just so that you can see kind of exactly how this works. So this project is called Kitty Drop. And basically the way it works is stuff falls from the sky. And in this case, I have the mouse controlling the way that the game works. So Scratch the Cat just kind of catches the items. And once he catches 10 of them, you'll notice that the game gets more complicated. It goes faster and faster. The actual little characters move faster. And then he's also got 9 lives. So every time that one of these items hits the ground, you lose a life. Okay, so this is the basics of what we're going to make with this game, but we're going to make a few modifications to it just to make it a little bit easier for the player to use and to make sure that the user experience is both fun and easy to use and easy to understand. So let's start first by setting up our controls for Scratch the Cat. So I'm going to move Scratch to the bottom of the screen. And if you're following along and you want to storyboard this out, would be to set up multiple storyboards for each of the different aspects of the game. So again, when I say a term like game mechanics, what I'm referring to is specifically the interactions that happen during the game. So right off the bat, just from our description and what you saw earlier, we talked about mechanics like the player successfully catches one of the items that's falling from the top of the screen. So we would want a storyboard for that. We also want a storyboard for a mechanic of if the player doesn't catch something on the top of the screen, how is that reacted? We also want to talk about maybe in the past we've also done where there are multiple categories of objects that fall from the top of the screen. And depending on what type of object it is, so in some cases we may have a food item, and food items are good for the character. So we might set up a storyboard for each one of the different items. Depending on what type of food item it is, we may choose to have some food items fall faster than others. We may choose to have bad food items like rotten fruit or rotten food, and those rotten food items take away a life. So we would have to storyboard that out. And one of the things you might notice from the example that I just showed is if you played that game for long enough and it gets faster and faster and faster, trying to predict where you need the character to go. So as you're playing, typically you'll watch the top of the screen. And one of the issues in that early version of the game is that our score and our high score cover up part of the top part of the screen. Okay, if you look at my screen right now that I'm showing, we typically set up this game using a backdrop. So I'm going to go ahead and do that and just choose one of the backdrops here. This blue sky one seems fine. And we typically place our character so that the character is standing on the ground. Okay. So one of the things that you'll want to consider when you're looking at the design of the gameplay is that if we include variables for the high score and the current score, which I do from the data window. So I'll create this for score. Actually, let's do current score. And then I'll do high score. If we leave those where they are, or even move them up here, we're going to cover just a little bit of the top part of the screen. And again, that isn't really helpful for people playing the game because we're covering up that portion of the screen that they need to be able to see where the items are falling from. But we have plenty of room down here at the bottom of the screen. And we know that we have plenty of room there because the character, Scratch the Cat, when he moves left and right, is not going to run into those. They're standing. And additionally, the top of our screen is clear. So we could also have our player lives. Okay. So that's a big, big piece of the user experience or the user interface piece that Christina talked about yesterday, is making sure that when you plan out your game, you look at those kinds of things. It might not seem like a big deal to put the score and things at the top of the screen. But again, if somebody, let's say somebody really, really loves your game and they're playing it over and over and over again, that's going to make things a lot more difficult for them. Okay, so now what we're going to do is we're going to run through, again, we'll be posting at the end of today's session the project, so you can see both the previous project that we set up, and you can look at the code that we set up for the prior project. But we're going to look at how to modify that code. So I'm actually going to take the code that we used from the last game. I'm going to modify it a little bit so that we're using the arrow keys instead of the mouse cursor. Which if you follow along with the previous sessions, you'll have seen this code already because we used it in one of the first sessions. And then I'm going to show you how to use the design tools to have both regular fruit and then our rotten fruit or food, so that we can determine which is the good ones and which are the bad ones. So let's go ahead and add in our controls first. So I'm going to run through this pretty quickly. Again, if you need to see the actual steps or the actual code, you can copy it from project. Okay, so I'm going to do the up arrow, down arrow, left, and right. So here's another piece of gameplay mechanics. As I mentioned, we have, in our previous example that I just showed, we have a control scheme where the player controls the character that they're using with the mouse. Okay, we're setting it up now so that we can control the player with our arrow keys. And actually, there is not going to be an up and down arrow, so we actually can remove those. And so when you're designing a game, you need to think about which is better for the player, which is easier, which is more fun, which offers a challenge. Do you want to allow them to use both the arrow keys or the mouse? Do you want to force them to use one or the other? Do you want to have two different game modes where one is using the mouse and the other is using the arrow keys? Is it fair if two players compete against each other using this game and one of them is using the arrow keys and the other one is using the mouse? You know, those are all considerations that you have to take into account when you're making a game. So we're going to set this up, and let's just make sure that this is working properly. Okay, so Scratch the Cat now moves left and right using the arrow keys. I'm also going to set his size to be a little bit smaller. We'll try 50%. And then we're going to move him so that he's touching the ground. Okay, again, if you're not sure about this code or what it does, feel free to check out one of the previous tutorials. We talk about this code pretty in-depth in prior sessions. And then I'm going to switch my rotation and point him in the right direction. Okay, so we've got our basic code set up to move the player left and right. Again, since there's no up movement in this, we're not going to set that up, but in our previous example, we have set that up before. So depending on the type of game that you're going to set up, you'll want to adjust that. And now we're going to add two new objects. We're going to add an apple and then we're going to make a rotten apple. So I'm actually going to start with the base apple, and then we're going to make adjustments to that. Again, we'll set our size to 50% like we did before. Okay, perfect. So now what I'm going to do is I'm going to take, since both of these will essentially function the same way, they're going to start at the top of the screen and fall down. I'm going to work on one of them first and set it up the way that I want. And then once that's set up properly, then I'm going to just copy my code to the other one. Because really the only difference that their motion, the only difference in their motion is that one of them is going to be rotten and one of them is not. So as far as that goes, there's no difference. They're going to move exactly the same way. The difference in how they behave is actually going to come in when the player catches them, because one is good, the other is bad, and then also what happens when it hits the ground. So let's start with our apple here. We're going to move the apple to the top of the screen, which if you followed along in the previous sessions, you'll know is 180. And that moves it to the top of the screen. But then for the X value, we want a random number. So I'm going to set this up to go from -240 to 240, because those are our screen coordinates from left and right. So now each time I click this, it should start at the top of the screen and move left and right. Okay, perfect. Now, once the game starts, I'll actually choose a repeat until block. And our floor, or our ground here, starts at about 160, -160. So I'm going to check to see if the Y position of our fruit is greater than, or sorry, less than -160. Okay. And if it is, then we're going to repeat over and over to change the Y value by -1. And what this will do is our Y value is just our position from top to bottom. So every time this loop goes around, it's going to cause the Y position of our apple to go down by -1. And based on our code here, it should stop once it hits our -160. Okay, so there we go. It's hit. The ground stopped, and there's nothing else going on here. Okay, so now our basic movement is done. And again, since this goes to a different part or a random spot on the screen, we can repeat this over and over and over again as much as we want. So now I'm going to copy that code and paste it right into our second object. And now both of them should go to a random spot and fall from the top of the screen. Okay, so now, again, as shown in the example, our game uses a game mechanic where there are multiple fruits that fall from the top of the screen at the same time, or at different times. They're staggered, and most of the time that timing is random between 1 second and maximum amount that we want, depending on how difficult or how hard our game is. So we're going to use a function of Scratch called clones to set up that game mechanic. And cloning is essentially just taking one object that we have and making copies of it or clones of it, so that every single one of those objects functions the same way, but is independent of all of the other ones. So if we go into our control section where we have all of our logic and our loops and things like that, I have an option that says when I start as a clone, where I can set up what I want to happen when each of these objects starts off as a clone. And in this case, really what I want them to do is to set their size to 50%, go to that random location, and then repeat down at the bottom. Or sorry, repeat until they hit the bottom. So every time I make a copy of one of these, I want those properties to be true. I want that to happen. Okay. So what I can do is I can set up my timer with my when green flag clicked and use my forever block, a wait block, and then this block down here that says create clone of myself. And the myself or the clone block has options so that you can choose any one of your objects. Okay, so in this case, since we're using Apple II, I can either choose Apple II or I can choose myself. Okay, so what's going to happen is when I click the green flag, and it's good to kind of follow along through the actual code block to see what happens here. But when I click the green flag, the first step of my recipe is the forever loop. So I'm going to go through this once and then repeat it over and over again. And I'm going to wait 1 second, which again, if you want to, you can pick a random number to put in here. Just make sure that the numbers that you input here are fun. You'll want to play around with this a little bit to make sure that the player is not sitting around waiting too long for this. And you might even want to set up variables for these because maybe you want the game to go faster like we did in our example game. And so you'll want these to pull from a variable so that you can adjust that variable if you want the stuff to fall faster. And then once it waits a random amount of time between a ½ second and 2 seconds, it makes a clone of Apple II. Okay? And that's when our code jumps here. When I start as clone, do these things. Set the size to 50%, go to a random location, repeat until the apple is down at the bottom. Okay? And then when we get to the end here, we jump back right here, and then we go through another loop. Okay? I've mentioned it a billion times before. I'm going to mention it again. Scratch will only do exactly what you tell it to do, when you tell it to do it, in the way that you tell it to do it. So this piece all happens simultaneously. So what's going to happen is this step will fire, then this step will fire, and then it immediately goes back to this step. So it's a wait, a clone, wait, clone, wait, clone. And every time that clone step hits, all of these things happen immediately. So we set the size, we go to the random location, and then we start this loop, and then jump here. Okay. So that seems to be working as intended. Now, the other thing that we want to do is we want to hide the apple before we tell it to pick its random location, and then show once it starts moving. Slightly different, but it kind of makes the game a little bit more clean looking, and the user kind of has a better experience when the apple doesn't just randomly show up as it's already falling. Okay, and now we want to set up what happens when the player actually catches it. So if we reference our storyboards, we have it set up so that the current score goes up by 1 when the player catches it. So we can put in an if-then block that says if we're touching Scratch the Cat, change current score by 1, which will raise that by 1. And then the other option, the last option that we have for clones, are to delete that clone. So obviously, since the player has caught it, we don't want it to keep falling. So we want to make sure that as soon as it touches Scratch the Cat, the score goes up by 1. Hard to get to that other side. Why I missed that first one. Let me try that again. Oh, because that first one is our other apple that we haven't copied this to. Okay. So now I'm going to duplicate all this code again back onto my first apple, because all of this so far is the same. We're going to make the change here if the bad apple touches Scratch the Cat. So let's duplicate this and paste it onto our other apple. And then let's grab this, paste that onto the first apple. Okay, so now I'm going to rename these just so that it's clear to us which one's the good apple, which one's the bad apple. Obviously, we'll know when we edit the graphics and change the visual design of this. But it also helps to have a name so that we can keep track of that for ourselves. And again, I've mentioned this a couple times, but this is just everything that we're doing right now is just like a recipe. The computer is just following this stuff in the order that we're telling it to do it. So the good apple right now, our recipe is correct. When Scratch the Cat catches it, or sorry, when the game starts, we create a clone, and then when Scratch the Cat catches it, the current score goes up by 1, and then we delete that apple. For the bad apple, we don't want the current score to go up by 1. We want the player lives to go down by 1. So we want to use a negative number. Okay, and we probably also want to hide our original apple. So let's make sure we add that too. There we go. Now I can't tell which ones are the good ones, which ones are the bad ones. And because the wait time in between the drops is random, there's not really going to be any way for me to tell, but you'll notice that my lives are going down. Score is going up depending on when I catch some of them. And I'll also want to delete that clone when it touches the ground. So let's add that to each of these. Now let's actually change our bad apple. Here's where we're going to introduce the visual design tools in Scratch. If you followed along with our previous training sessions, we touched on these a little bit in making some of our other objects, but we only did some very, very simple work with them. So now we're going to do a little bit more complex work with these. So the first step is our object here is what's called a vector object. There are two different types of objects in Scratch. So yeah, Christina just said, let's change the bad apple's color. That's exactly what we're going to do, and we're probably going to draw some edges on the side so that it looks like somebody took a bite out of it. So it really is a rotted, half-eaten apple. But there are two different types of visual graphics in Scratch. There are what are called vector graphics and what are called bitmap graphics. And if you look down in the bottom right-hand corner here, you can tell which type of graphic or which mode you're in. And depending on what you're trying to do, you're going to see different tools that are available to you. So vector tools are the ones we're going to start with, and then we're going to change this probably to be a bitmap graphic, or I'll just show you the bitmap tools separately. But our vector tools essentially are mathematical tools. So we can create shapes and lines and squiggles and different things like that just by clicking and dragging to make our objects, but because they're mathematically drawn, if we make a square, for example, we can go back after the fact and click on our selection tool up here at the top and still make changes to these. So I can change the size just by dragging. Okay. On the other hand, I'm going to just put in a new costume. And this one, if I start a new costume by painting, you'll see the other tool, which is bitmap mode. And bitmap mode, you'll notice the tools are no longer on the right-hand side. They're on the left-hand side. These tools are just like it sounds. You're actually painting something. So once we click off of that shape, I can no longer come back and select that to move it around or change the size. I actually have to either erase it using this erase tool, or I have to paint over it with either a different color or a different shape or something along those lines. Okay. Regardless of which mode you use, whether it's vector mode or bitmap mode, and again, you can tell pretty easily down here at the bottom, but also by the side of the screen that the tools are on. You'll have the same color options and the same width options for your line widths for the borders of your shapes. So this part won't change. You can zoom in, you can zoom out. Those are exactly the same for both modes. The only tools that change are the ones that are here on the right or left-hand sides. Okay. So I'm going to start in vector mode, and we're going to change the color of the shape. So I'm going to choose something. Good. Cool color. Something that looks real nasty. And so here are my tools that I have. I'm using the paint drop tool, or the paint bucket tool, but let's go through these. So the first tool is the select tool. The select tool lets me click an object and move it around. Okay, I have a handle up here at the top that I can use to rotate the tool. I have squares that I can use to resize the item. And then up at the top here, I have undo tools, redo tools, and the ability to flip upside down, left, right, which doesn't really make a difference, but it might help for our visual cues. I have a reshape tool that I'm not sure if this will let me do it for here. So here I have actually two separate shapes, one for the border of the apple, and then one for the outer edge. I've also got the same shapes up here. If I click on these items, I can actually reshape every single one of these. I can undo all those steps if I want to. I can redo. But literally all I have to do is click on the shape that I want, and then I can drag these little points around to make changes to my shape. Okay. I can also add these handles by clicking on an existing shape somewhere where there is not an anchor point. So if I click on this inside shape and then click here, I'll get a point in here that I can use. Okay. I've also got a pencil tool. The pencil tool allows me to draw lines and squiggles that I, again, can then reshape, resize, rotate, move around. I can use the reshape tool to adjust each of those points. And I can also delete that entire shape or that entire section. Additionally, just like I showed with the apple, I can also remove tools or anchor points just by clicking on them. So we can make shapes more complex or less complex just by clicking on them. So clicking on an anchor point removes it. Dragging it around changes it. Clicking on a spot that doesn't have an anchor point adds an anchor point. And using the selection tool deletes the entire object. Okay. We also have lines. So these are just straight lines. And again, all the same tools apply as with the other ones. We have a rectangle tool, which is any width or height that you want. If you want to make sure that this is squared, you can hold down the Shift key on the keyboard, and that'll constrain it to a square. You have a circle tool or ellipse tool. Again, ellipse, whatever width and height you want. If you hold down the Shift key, it'll snap to a constrained circle. So it's always the same width and height. We have text tools, which text tools you just click to type something. And then we can move it around. We can rotate, we can resize. For the text tool, you have the ability to change your font. There's not very many fonts available in Scratch, but you have them if you want to use them. We've got a paint bucket tool, which we kind of already used, where we can modify these colors. Something a little crazier looking. I'm going to undo. I kind of like my original better. And then lastly, we have a duplicate tool, which basically lets you just take a shape. The duplicate tool works just by clicking and dragging. Oops. So if I click the duplicate tool, I can just click on the object, drag it to get the second one. And then there's some additional tools that you only have when you have something highlighted. And these are basically our layering tools. So if I duplicate this apple, I can move it around and move something behind or above another shape. And then I can also make that item move or ungroup. So now I get the individual pieces of my apple. So you can kind of see how they made these shapes actually by doing that. Okay. Along those same lines, if I have multiple items selected, so if I click on one item, hold down the Shift key and click on a second one, I can move them around together. And then my ungroup tool changes to a group tool. So it's just kind of context sensitive. Depending on what you're trying to do or what you're attempting to do, you'll get a different selection for both. Okay, so those are our vector tools. Now, our second piece is we can either continue using these. I would like to actually use our tools here, but I do want to show off the bitmap tools first. So what I'm going to do is I'm going to duplicate this costume and convert it to a bitmap. We're going to make our final changes in our first costume, but I want to show you some notable differences with the bitmap tool. So one of the first things that you'll see when we convert something to a bitmap is that it becomes grainy or jagged. Okay, as I mentioned before, vector tools are mathematically based. So with mathematically based tools, you can have perfect curves, perfect lines. Everything about it is perfect. It doesn't look too much different when we switch back and forth between our bitmap and vector version. But if you zoom in, you can see those pixels. Because bitmap tools are painted, there are actual pixels involved with actually doing the painting. So our tools are very similar to the vector tools. We have a brush that we can use to paint. Again, once we've painted, though, we can't go back and move this around or modify it. We can draw lines. We can draw rectangles or squares. We can draw ellipses or circles. We can write text. We can change a fill color of something. Okay. With bitmap tools, the fill color only modifies pixels that are within a certain range of being the same color. Okay, so notice that because we used a gradient, we can only change each individual segment of the gradient. We have our eraser that actually erases stuff off the canvas. We have a selection tool so we can highlight different pixels and move them around. We have a magic wand tool that will attempt to highlight pixels of the same color. So if we kind of highlight the part that we want to keep, it will remove a background from a photo. You'll kind of notice that it highlights it, and then we can delete it or get rid of it. And then again, we have the select and duplicate tool. So we can select something and make a copy of it. Very similar to our vector tools, but again, because these are painted, they're pixels. We can't come back after the fact and move this stuff around the same way that we can with vector tools. Okay. I prefer vector tools in most cases, depending on what you're doing, depending on the project. You may find that one is better than the other. It's completely up to you. Again, I like using the vector tools because I find that they're easiest to use. So I'm going to add some shapes here. My apple look like there's been a bite taken out of it. Maybe put in some little teeth marks. Kind of maybe looks like there's been a bite taken out of it. And then we'll do the same on this other side here. Can move my shade piece. Maybe even rotate it a little bit so that it fits more over here. Keep reshaping this. And again, all I'm doing is clicking to add anchor points and then moving them around. If you want to make sharper anchor points, you'll have to just kind of add anchor points close by. That should get the point across, and then we'll reshape these. And this doesn't have to be perfect. We actually probably don't want it to be completely perfect, so I'm going to send this guy to the back so that we can actually see our other shape. Again, we may want to add anchor points to kind of smooth this out and match up where all this stuff is. We may even want to remove these middle points and just have it be the outside section. And then we can really kind of click wherever we want to match these up. So the point is, depending on how much time you want to take, how much effort you want to put into matching these, you can get it reasonably close though. You just kind of have to get used to some of the quirks is really the biggest takeaway. But as we mentioned before, using this tool will give you, I think, much better results because you can always move stuff over after the fact. So use at your discretion. And now we've kind of matched them up a little bit. Okay, so now if I jump back, you'll notice that my game updated right away. Christina said that apple looks poisoned, don't catch it. You got it. Now my poison apples are falling. Good. Okay. And now I just need to make sure that my regular apple is working as well. Good apple. So now I should have both good apples and bad apples falling. And again, depending on how you set your project up, you can add in different speeds for these objects. Oh, I caught a bad apple. I was not trying to do that. We have the basic game mechanic working. Now, the last part of our game mechanic, of our game design that we need to put in is the actual scoring system. So we've already kind of done this, the change score and the player lives going down. But we also need to set that stuff up when our game starts. So right here in Scratch the Cat, and you can usually do this in one of two ways. You can put it on the main player character, or you can put it on the stage, which is where I typically like to put stuff. Anything that affects the entire game, I like to put on the stage. And in this case, we want to make sure that we set our player lives to 9 lives. Scratch is a cat after all. Set our current score to 0. So every time we start the game, our scores reset. But then we also want to put in a block that is constantly checking if our high score is greater than our current score. And if it is, then we want to set the high score to whatever that current score is. Okay, so when we click the green flag, our players' lives go back up to 9. Our current score is 0. Our high score, current score, then set the high score to current score. The last piece that you may want to add in here is within this forever loop, you may also want to check if the players' lives drop to 0. And then if they do, you may want to put in like a you lose message or something like that. You can put in a control here that says if the player lives is less than 1. We could do also equals to 0, but this is kind of one of those gotchas that I always talk about. If we set it to 0 and we happen to catch 2 bad apples at the same time, it's possible for our score to actually skip past 0 and go right to -1, and then that equals 0 condition wouldn't actually apply. But we can send a message when the player lives get to 0, and that could be just a message that Scratch to Cat says. So I'm going to broadcast game over. And then I can tell Scratch to Cat when he gets game over, he needs to say, "Oh no, we lost." And then he can stop the entire game. Okay, so let's test this. So now we've got our good apple, our bad apple, Scratch the Cat, and we should have our basic game in place. So our scores reset, our lives reset back to 9. I'm going to test first losing, make sure that oh no, we lost. And then our game should stop. Okay, so you may not have noticed, but once the game stops or the Scratch the Cat script stop, you can't move left and right anymore. If you want to stop the entire game, then you can also set that up on the stage and put stop all, and that'll stop the entire game. You'll also want to set that up for the apples so that the apples stop falling. And then it looks like our score is going up as well. The only thing that's not currently working is our high score. So we'll need to see what's going on with that. Okay, there we go. So then we lost. The stop all on the stage stops the entire game. Okay, so let's check our high score, why that isn't working. If high score is greater, if I put these in backwards, if current score is greater than high score, then set the high score to the current score. So now, as we play, our high score should automatically set itself. Lives are working, high score is working. The difference with the high score, the only thing that we haven't done, and you probably shouldn't do this if you are going to be keeping track of a high score, the project actually saves variables in between uses. So when I hit the green flag, we're not resetting the high score in our blocks here, and that's because we want to keep the high score. Obviously, it's not a high score if it resets every time. So looks like our game is working, though. All righty. So that brings us to the top of the hour. So we have a little bit more time. I'm going to stick around for the next half hour. Christina, if she wants to, can stick around for the next half hour as well. We're open-ended for questions. If anybody has any questions about the topics that we covered today. The homework from today's session to tomorrow's session is to figure out a way to get a variable speed so that once the player's score hits a multiple of 10, like in our sample game, that score will drop. Or sorry, not the score will drop, but the speed will go faster so that the apples, the good and bad apples, will drop faster. You can set it up so that they fall at different speeds if you want. You know, one of them is much faster, one of them slower, however you want. But the homework is to figure out a way, and I'll give you a hint that you're going to need to use variables, is how to use variables to set up a variable speed that increases when the player hits a certain score or a certain multiple of their score. We'll check in tomorrow, and then after tomorrow's session, I'll have the sample project up that has all of this game plus the homework from today when we give the answer tomorrow. So we'll stick around for a little while longer, maybe up to a half hour, to answer any questions that you guys have. And again, we're checking for questions on our YouTube channel under the live chat or under the comments, and then also in the chat window on the right-hand side of the Hangout. So let us know if you have any questions or need anything. But other than that, that is it for our session today, and I'll see you guys tomorrow. Again, if you're not sure how to chat with us or how to ask questions, if you move your mouse to the left-hand side of the Hangout window, you'll see some icons. The first one is the chat icon up at the top, and that'll let you type in some questions. And then also, as I mentioned, we also have a live chat window on the YouTube page, and then you can also leave comments down here after the video is over if you don't really have questions that you want to ask now, but you think of something before our session tomorrow.